Hey, chemistry students. So, in our last unit, we took a look at what were called electron configurations. And if you remember the 1s2, 2s2, and so forth, right? These electron configurations are going to help us to be able to understand some things about the periodic table, some patterns that we find in the periodic table. Now, our next unit here is about trends in the period. It's called periodic trends. It's about trends that we find in the elements, and we find those trends on the periodic table, right? And our first lesson in this unit is going to be about the organization of the periodic table. So the third unit here is pretty much about the periodic table and the patterns that we find in it. Today we're going to talk about some of the organization, how the periodic table is organized. And our target is to be able to describe the organization in the modern periodic table. So let's take a look at the periodic table and see some of the stuff about how it's put together and organized. Okay, so at this point we've all worked with the periodic table before. In our last unit, we looked at the periodic table a little bit. We talked a little bit about the elements in the periodic table, and we learned how to write the electron configurations for those elements. And now, looking at the periodic table, we're going to understand how those electron configurations go into the organization of the periodic table. But first, let's talk a little bit about how we came to have a periodic table, a little bit of history about it. In the middle of the 1800s, there were not that many elements that were known. Today there's 118 elements on our periodic table, but at the time there were maybe only a couple of dozen. I mean, there wasn't that many. And at the time, if you were learning about chemistry, it wasn't really so many elements that you couldn't just memorize their properties, right? But what was going on at the time in the middle of the 1800s is more and more elements were being discovered. And it got to be that there were enough, that there were kind of too many for you to just memorize the properties of the different elements. And so there was a chemistry teacher in Russia by the name of Dmitry Mendeleev. And what Mendeleev did is he wanted to create some kind of chart so that his students wouldn't have to memorize the properties of all of the different elements. And so he took little cards with the elements and their properties on them. He moved them around, he switched them around until he found a nice pattern that made sense. And that was kind of the first periodic table. And what was really cool about this periodic table is he had to make gaps in it in order to make different patterns line up properly. And he predicted that those gaps in his table would correspond to elements that hadn't been discovered yet. There were 3 of them. And so he predicted the existence of elements that nobody had ever discovered before, just by organizing the elements into a table. And over the next few years, I think it took about 15 years, but eventually those 3 elements that he predicted were discovered. Right? So Dmitry Mendeleev is credited with invention of the periodic table. Now there is a lot of information on the periodic table, right? Some of the information you can find in the boxes, right? Some of the information is in the organization of the table. So let's just take a minute and talk about the information that you find in the boxes, right? Most periodic tables are going to have certain pieces of information in those boxes. They're not all the same. People who publish different periodic tables will choose to put different information in those boxes. One piece that you're probably always going to find is the atomic number. And if you remember, we learned about atomic number. Atomic number tells you how many protons are in the nucleus of an atom of that element, right? And if you look at the periodic table, you can see it's mostly organized by atomic number, right? We start up in the upper left corner with number 1, and then across the way we see number 2. Then you go down to the next row and you find number 3 and 4, and then 5 and 6, 7, 8, 9, and so forth, right? So they go up in an ascending kind of way. And most periodic tables will have the atomic number in the box. You'll also probably find the element's name and or the element's symbol, right? So it might say oxygen, O, or it might just say O. or it might just say oxygen, right? Depending on the periodic table you're looking at. But most of them will tell you which element it is in that box. Also very common in boxes on periodic tables, it's called the atomic weight. You see at the bottom here there is a number, a decimal number, and this decimal number is called the atomic weight. And what it is it's the average weight of all the different isotopes of that element that occur naturally, weighted according to their abundance in nature. Yeah, it's the average weight of an atom of that element, basically, right? Weighted according to its abundance in nature. Anyway, that's the atomic weight, right? And we're not really going to use that number very much right now, but later in the class, especially when we start doing some calculations having to do with chemical reactions, we'll use that number an awful lot later on, right? But right now, we're not going to use it so much. And there can be other information in the boxes, right? If you look very closely at the periodic table on my wall, there's some micro print, right? Tiny, tiny little printed letters with lots of different information about those elements. That information doesn't always have to be printed in the boxes, right? Sometimes people choose to put in the boxes information about maybe the electron configuration or some of the other properties that have to do with that element, right? So depending on who's publishing that particular periodic table, there could be lots of different information in it. And if you go to the front of the room and you look very closely at one of the boxes of my periodic table, there's lots of tiny little print that tells you about lots of different properties of those different elements. Okay, here's the periodic table at the front of my classroom, right? Let's talk about some of the different features and some of the different places on this table and understand how we talk about some things. There's some things here that we call certain names, some vocabulary here to talk about, okay? So, like we mentioned a minute ago, the elements on the table are organized by their atomic numbers, right? If you go across the way, you'll see the atomic numbers get larger and larger and larger. Smaller ones, smallest ones up here, and the largest ones down towards this corner of the table, right? Originally, it's kind of interesting, the periodic table was originally organized according to the atomic mass, right? According to the atomic weight. And this led to a few of the elements being slightly out of place. When you organize them by that weight, they actually end up in pretty much the same order, except for a couple here and there. I couldn't find them behind me, turned around, right? But over here, there's a couple that end up being in the reverse order, right? But when you put them in order by their atomic number, they end up in this order. And this order is actually much better, because what you find when you put them in this order is that if you break it off here and start a new row, then what happens is a lot of times the elements that go down have very similar properties. So the elements that are over here, lithium, sodium, potassium, rubidium, these ones all have very similar properties. These ones here, beryllium, magnesium, calcium, and so forth, right? All have very similar properties. So when you organize them by their atomic number and you break the row off right over here and start a new one, they end up lined up pretty well by their properties. And what's also very interesting, you saw in the activity at the end of Unit 2, is that when you organize them this way, they end up getting organized by their electron configurations as well. Hopefully you saw in that activity that the ones over here in these two columns all have an electron configuration that ends with an s orbital, right? We call these two columns the s block. You saw these ones in this whole block over here had electron configurations that ended with a p orbital. We call this the p block, right? Now, kind of a word that we should be familiar with, the s block and the p block together, we call the main group, right? So s block and p block is the main group. Hopefully you saw that these ones here in the middle all ended with a d orbital. We call this the d block. Sometimes people will call it the transition metals, right? Or the transition elements. And that's all of these ones right here that are kind of set down. And then I don't think you had it on the activity you did the other day, but the ones that are way down here all end with an F orbital, right? And so this is called the F block. The ones that are down here, these ones down here, are actually pulled out of the table right here. If you didn't pull them out, what would happen is this periodic table would be very long, right? You would have a gradual step down there with this one here, and that would step back up for these ones and these ones, right? But it would be very, very long. It would be hard to put it on a poster and put it on the wall. It would be hard to print it off on a piece of paper and put it in a book, right? It would look something like this. It would be very long, and it would be kind of difficult to work with, right? And so what they do is they pull this F block out and they put it down here, kind of outside of the table there. These elements in the F block are sometimes called the rare earth elements or the rare earth metals, right? Because they're fairly rare. The ones in the first row here, in row 6, are called the lanthanides, because the first one is lanthanum. And the ones in row 7 here are called the actinides, because the first one there is actinium, right? Let's see. So we've got the main group, which is the S block and the P block. We've got the D block, which is the transition metals. And we've got the F block, which is the rare earth elements, right? Now, we can often refer to a place on the periodic table where these are using a number for the row and for the column. Okay? These elements are organized into rows. Rows go across this way, right? And you can see each row is numbered. There's row 1, 2, 3, 4, 5, 6, 7, and then these ones belong in rows 6 and 7, right? Rows are often also called periods. So we would refer to this as period 4, period 5, and so forth. We can also refer to columns. Columns are up and down vertically, right? So here we have column 1, column 2, and so forth, going all the way across to column 18. So if I ask you about an element that's in period 2, column 2, you could just look right over here and say, oh, that's beryllium, right? And you can see there are places where no element exists, right? If I look at period 1, column 3, there's no element there, right? That would actually fall in the P block in row 1, and there is no 1p orbital, which is why there's no element there, right? So much of this space up here that's empty is because there's no 1p orbital. There's no 2d orbital, and so forth, right? So there's some interesting ways there about how the periodic table is organized. Okay, something to mention here that's really kind of neat, and it's almost amazing how this works out, right? When we organize the periodic table by its atomic numbers and by the electron configurations and whatnot, then what happens? We get something interesting that comes out, right? Look at this right here. This right here shows you which elements are metals, which elements are non-metals, and which elements are sometimes act like metals and sometimes act like non-metals. We call them metalloids. And what you'll notice, this is really neat, all the metals end up in the same place, grouped together on the periodic table. And then all the non-metals end up in another place, grouped together on the periodic table. And then the metalloids end up clustered right there in between them. And I don't know, I think it's really neat. We organize the table by very different things, and this just kind of happens to happen, that metals and non-metals and metalloids are all grouped together there, right? So I think that's something that's pretty neat. One kind of oddball thing to think about here, there are people who argue about where helium belongs on the periodic table. You can see on mine right here, it's over here in column 18. These other elements right here in column 18 are called noble gases. And helium has properties very similar to the other noble gases, right? They all have very similar properties. They're not very reactive. They all end with an electron configuration that contains p6. So it's, p6. So neon ends with 2p6, argon 3p6, krypton 4p6, and so forth, right? Helium is too small to have a p orbital, right? So helium's entire electron configuration is 1s2. And so, it's got a full last orbital, just like all the other ones here, right? Helium ends up with properties very similar to all of these other elements. But with its electron configuration, 1s2, it's much more like these ones, right? Because beryllium, its last orbital will be 2s2, and 3s2, 4s2, 5, and so forth, right? So helium has an electron configuration much more like these ones, but it has properties much more like these ones. So you can debate where helium belongs. Sometimes, especially on older periodic tables, you'll see it right here next to hydrogen. Sometimes you'll see it right here. And sometimes people will put it both places, right? So helium will appear twice on the table, once over here and once over here. Helium really kind of makes sense in both places. Alright, there is some information there about the periodic table, about how it's organized, what we call some of the different parts, a little bit about some of the different properties that we find on there. Some interesting stuff. Next time, we'll go ahead and we'll talk about what are called some of the families of elements. Families of elements are found together in the same columns on the periodic table. So hopefully that helps us to be able to describe the organization of the modern periodic table. So until next time, take it easy.